So we looked at patterns, we looked at setting some writing some equations. Last week we looked at identifying functions, linear, quadratic, and exponential. We looked at on Thursday what exactly is a function. Can someone give us the definition of an actual function? What a function is? Yes?
A function where every number of the domain has at most one member in range.
Okay, so every x has a y. Every member of the domain has a member of the range. Every independent variable matches to exactly one dependent variable. Okay? So everything on this paper are functions. Okay? So when it says parent function at the top. There is a copy of them over there on the wall. I want to walk through and give you some characteristics of each one. Very quickly, we're going to go through the sheet, looking at these functions, and then we'll be working with one of the specific types of functions. Okay? So I do realize some people are leaving at 2:15 cross country, volleyball at 2:40, 2:45. Who else is leaving? Was it cross country is 2:45 or
2:15, sir.
Who else is leaving? Volleyball is leaving at what time?
2:45.
2:40. Who else is leaving?
That's it, sir.
All right. So you don't need to interrupt at 2:15. You don't need to interrupt. Just grab your stuff and go. Everyone else knows you're leaving. 2:40. We should be done. I hope by then. So.
And you said so.
Yes.
So would it be recorded on Schoology? Yeah, you see the mic on at the bottom.
So.
Oh yeah.
Yeah,
forgot.
you're actually. That question will be on there as well. It's already recorded. So there's a link on Schoology that should take you to the YouTube page. I'm trying to get it opened for Center, but right now it's not. So you have to open it on home or on a different computer or your phone.
All right.
But I'll try to get it open for you. There's just a link. If it doesn't work, let me know. Precoptus is having some issues. It opens up perfectly for me on whatever device, school or home or my whatever. Some of the computers are not open. I don't know why. So if you have any issues, let me know, but it will be out there. Okay, so parent function. Very first one is linear. The general function is going to be, let's make sure I put this down right, f of x, oops, f of x equals x. Now, understand, linear functions can take all shapes, all types of forms. This is a linear function, 3x minus 4. This is a function x plus 2. We've done things to it. We've shifted it up or down, left to right. We can make it, with quadratic, we can make them wider and narrower. We can do stuff with it. We're looking at what's called the parent function. This is the most basic, the one we want to study, okay? So, linear function, f of x equals x, it looks like this. It goes from here, right through the x. Think about it, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Same thing down. It's a straight line, left to right. Okay, so what's the domain of a linear function? Say it again. So x is the value, but what value can go in for x?
One, all the numbers, I guess.
All real numbers.
Oh, I remember.
There's not a number you cannot
What
put
does
in
that
for
say?
x.
What does that say?
R.
So, hold on. I forget. You guys probably may not have seen that before.
No.
So you can go negative infinity to infinity.
Oh, okay.
You've seen that before, right?
Yeah.
There's a fancy way to do it. It's a fancy R. 2 lines, and then an R. And that means real numbers. All real values. It's right up here. Okay? Fancy R means all real numbers. Okay, so the domain is all real. The range is exactly the same. All real. It can be any number on the number line. I'm not going to critique your art. I appreciate that.
I'm just gonna put that.
All right, fantastic. On the x-intercept, the x-intercept of the parent function is 0, 0, which obviously the y-intercept is the same. It goes through, and while we're talking about it, what do we refer to that point as?
All real numbers. Oh.
That point right there.
Origin.
That is called the origin. Outstanding. That is the origin. So it's the x-intercept and the y-intercept are both at the origin. the maximum number of roots or zeros. If you want to put another word in there, okay, it's the number of x-intercepts. Whenever it crosses the x-axis, that's called a root or a zero. Okay? So in this case, the maximum number is 1. It's only going to cross the x-axis at most once. And in fact, all linear equations will cross the x-axis somewhere. All right, 2 more things to talk about. I'm going to kind of tell you what we're referring to, and then as we go down, hopefully it becomes a little more obvious. The end behavior. Okay? So what we're referring to there is as x is getting bigger, as x goes to infinity, so as x is going this way, what's happening to the y?
It's going down.
You might want to get the right answer before you shout it out. Maybe not shout any more answers. What's happening to the y? It's going up.
I knew that.
As we go to the right, it goes up. So as x goes to infinity, as x goes to infinity, so does y. So does f of x. It also goes to infinity. The second row says, as x goes, and this one we're going to look as it goes to the left. So as x gets smaller, as x gets to negative infinity, what's happening to y? Once again, it's going down to negative infinity.
That makes sense.
So in behavior, the first one will always be as x goes to infinity. The second will be as x goes to negative. What's happening to the y? Is it getting bigger? Is it going to a number? I'll have one to actually go to 0. Now, this next to it says continuous and discontinuous, and a lot of kids don't understand what that means. Continuous doesn't mean it goes on forever. That's not what it refers to. Continuous means you can create the function without lifting your pen. Okay? So I can start anywhere on here, and as I create this, there's no breaks, there's no gaps, it's nice and smooth, and there's no breaks, there's no holes in the graph. I can create it without lifting my pen. So this is definitely continuous. I can draw it, I can create the graph without lifting my pen. We'll have a couple, I think at least 1, maybe 2, that will not be true. All right, now I am not going to explain roots again in behavior or continuous or discontinuous. We're just going to go through the rest. If something comes up and you have a question about it, please stop and ask. Okay? Absolute value. Looks something like this. F of x equals, and then absolute value is 2 lines. Hopefully you've seen that before. 2 lines up and down. And absolute value simply means distance from 0. Looks like that. It's actually another grouping symbol. We can have brackets, parentheses. Absolute value is another grouping symbol. And the function looks something like a V. It comes down, and then it goes back up. Something like that.
So,
V value. Yes, sir.
so I know you like took off your pen, but that's continuous, right?
It is, because I can create it without lifting my pen. Yep. Okay, so domain, all reals. Because anything, you take the absolute value of any real number. Decimal fraction, doesn't matter. Range is not all reals. What are the y values here? How low does absolute value go? Yes?
0.
It goes down to 0. So I'm going to put a bracket because it's closed, 0, but then it does go up forever. So up to infinity. So the range goes far down at 0, goes up to infinity. You can tell the x and y intercepts, they're what? What are the x and y intercepts?
0, 0.
They're both the origin. Yep. 0, 0. 0, 0. Be careful. What's the maximum number of roots an absolute value function can have? Yes?
1.
Well, the parent function only has one. But could I move this graph to somehow get more than one?
Yeah.
How?
If you just put it in one quadrant.
Sure. If I just even just shift it down.
Yeah.
So what's the maximum times it can cross the x-axis?
2.
Okay, it could cross it twice. Could I ever get it to cross 3 times?
Yes.
Yeah, absolutely. Wait, yeah.
How?
Because
Maximum
wait,
is
that only
two.
comes going up to y.
Okay.
Technically, this is the
Okay.
x.
Maximum is 2. And most you can do is get 2 out of it.
Oh, I didn't know.
All right, in behavior, as x goes to infinity, as x is getting bigger, it's the same as the linear. The y is getting bigger and bigger as well. As x is going to the left, as x is going to negative infinity, it's moving this direction, the y is also moving up. So it goes off to infinity. And I think Cameron already suggested that this is continuous. All right, any questions on absolute value? Have you guys gone over all these functions before?
No.
All right, let's keep going, quadratic.
I don't remember.
I don't.
All right, f of x. Thank you. F of x equals, quadratic is anything to the second power, so x squared. Your parent function is going to go through 0, 0, 1, 1, 2, 4. It's going to look something like that.
What was the thing going through?
0, 0, 1, 1, 2, 4. I mean, think about it. If I put a 2 here, what's 2 squared? So it goes through 2, 4.
Oh.
And then you just reflect it, negative 1 squared, 1 is 1. Negative 1, 1, negative 2, 4. Okay, and pretty much everything to me looks like it's the same as the absolute value. The domain is all reals. The range is all reals. Nope. What's the domain? 0 to, make sure you put a bracket on it. The bracket with 0, it's closed. It actually goes to 0.
Wait,
Yes.
so would I put the bracket on the absolute value for both sides, or would it be parentheses on the next? Would it be bracket and parentheses, so would it be?
The bracket should be the exact same thing. Bracket on 0, parenthesis on.
Okay.
I'm sorry, what? Because it can't actually get to 0. So because it can't actually, it's closed. It's a closed interval. Okay, so x-intercept's the same, 0, 0. Y-intercept 0, 0. Maximum number of roots would be the same, 2. As x goes to infinity, y is getting bigger, the same as absolute value. Negative infinity goes to infinity, and certainly continues. The only difference is absolute value is a v, quadratic is a u. It's the only difference. Everything else is identical. All the other characters.
Please excuse this interruption. This is not the veil. We need the cross-country team released at this time. We need Cameron Brigham, Promise Cunningham, Milton Brown, Ramon Franklin, Brennan Eubanks, Rose Vick, Tanisha Williams, Javante Wilcox, Tamara Williams, Gwendolyn Hicks, Genova Martinez, Tamara Dole, Gia Hyder, and Lee Hart. If those following students can report now, the cross-country team, teachers, please refer to your email. Only those students listed on that cross-country email should be released at this time. And also the JV game, the JV football game against Lincoln tonight has been canceled at this time. Again, the JV game against Lincoln tonight, football game has been canceled. Thank you.
Okay, here we go. Let's get back to it. So the next one is cubic. F of x equals x cubed, third power. And it looks something like an S curve. So in this case, what values are part of the domain? What values can I put in for x? All reals. I can put any value in for x that I want and cube it. Now the range continues to go up, continues to go down. So that means the range is also all reals. It's kind of hard to tell on my graph, but the x and y intercept are both at the origin. What's the maximum, be careful, what's the maximum number of roots a cubic can have? It's more than one.
Four.
Oh, who said 3? Yeah. Let me show you an example. You could possibly have a cubic function make some twists and turns a little bit. So it actually could look like up and down and back up. 1, 2. So it could have at most 3. Okay? Now, a little helpful hint. Over up here we said the quadratic x squared had at most 2 roots. Cubic now has potential of 3 roots. So how do you think you could tell in future problems? Logan?
What the exponent is.
Yes, and it's actually called the degree. This is a 3rd degree polynomial. So it can have at most 3 roots. If I have a 4th degree, at most 4 roots. 5th degree, at most 5, so. Okay, so, in behavior, as x goes to infinity, y also goes to infinity. As x goes to negative infinity, y also goes to negative infinity. And of course, you can sketch without lifting your pen. Okay, so let's try this. Okay. I'm going to go through, I'm going to give you the function and the graph, and I'm going to give you a few minutes to try and fill out the other side, fill out the characteristics, okay? So let's go through this next one pretty quickly. I'm going to give you the function and the graph, and we'll save the other part for you, okay? Let's give it a try. Number 1, square root function. F of x equals the square root of x. Now we know that x can't be what type of value? They can be fractions, they can be decimals, they can be 0. I think I heard someone say it louder. What'd you say?
Negative?
It can't be negative. Okay. So my graph is going to look something like this. All in the first quadrant. Looks something like that. All right, I'll save the rest for you here in just a minute. Don't start on it just yet, I'm going to give you time. Okay? Cubed root, f of x equals, and this is going to have a radical sign, and the index is a little 3. Cubed root. Okay? Now, just to make sure we understand what cubed roots are, if I give you the cubed root of 8, that happens to be what value? 2. Because we have the number 3, right? 2 times 2 times 2 equals what number times itself? 3 times equals 8. So that's what cubed root is.
Oh.
All right, now your function looks pretty cool. It looks a lot like the cube function, except it's on its side. Looks something like that. Looks very much like the cubic function, except lazy, it's laid down. Give me a second to finish that one. What do you mean doesn't have a point?
Can't be anything forever.
I think what he's asking is that like, is that a endpoint?
Oh, no, these are arrows. These are arrows.
Yeah.
Sorry. They do go on forever. both directions, keep going. Keep going, hint, that's your range. All right, reciprocal function. Okay. Reciprocal function, f of x equals 1 over x. F of x equals 1 over x. X is in the denominator, which means, little hint, what can x not be?
Higher than one.
No? X can be 5, that would just be 1/5.
Zero?
X cannot be 0,
Oh.
because you cannot have 0 in the denominator. So x cannot be 0. That's your domain, by the way. Everything except 0. So when we graph it, it's going to look something like this. And then it's going to do the same thing in the first quadrant. Something like that. Kind of looks like maybe an inverse or an exponential function, just two of them. Yes?
Is that one function or is that just one example of functions, one on the x?
That, sir, is a fantastic question. Say it nice and loud and people stop talking, and ask the question again.
Is that just one function or is that one of each of the functions it can be?
Why do you ask that?
Because it's two lines, but they don't look like they intersect.
And they don't, and it is one function. Say it again. So that means it is discontinuous, because there's a break. You cannot create that graph without lifting your pen, and it is one function. Great question. And by the way, that's the only one we have on here that's going to be discontinuous. Everything else is continuous. Okay? Logan,
How?
how what?
How is it one function?
I don't understand your question.
How is it only one function
It's just in pieces.
if
It's just it's one function. If you start, okay, shh. Okay, so if you just set up a table and start plugging in values like 0, 1, 2, 3. Still with me, Logan?
Yeah.
-1, -2, -3. You'll start seeing all these values show up, except for 0. We have this problem. Now, since we're here and you asked the question, let me address it and then I'll get to your question for just a second. Right here, we have another mathematical concept. I'm going to put a dotted line in there. Okay? Does anyone know what that dotted line is called? The function is getting closer and closer and closer from both sides, but it never actually gets to x equals 0. Because when I put in 0, that's undefined. You can't do that. So, but I can get closer and closer and closer to x equals 0, but never actually get there. Okay? And that's what we call, you gotta be careful when you say it, an asymptote.
That's what I was gonna ask you, what it meant.
There you go. It's an asymptote. An asymptote is a line you're getting closer to, but you never actually get there.
Oh,
Okay? We're going to talk more about that when we get to that point, but just introduce the term. Yes.
so, is the asymptote only applied to like the y and the x? Oh, or is it only applied to the x or the y?
So we can sometimes have a horizontal asymptote. Oops. And it can be anywhere on any value. We can also have a vertical asymptote. It can be anywhere left or right. You can also have a diagonal asymptote.
So is it asking us how many asymptotes the function has?
Do you guys see another potential asymptote in here? Cordell?
It'll be a diagonal one.
Could be three.
It's not going to be, that's a very good one. It's not going to be
The
diagonal.
opposite?
Yes,
Is it horizontal?
it is. Right there.
Oh, because there's two then.
Because there's absolutely no value that you can put in for x that will cause this to be equal to 0. That's never going to happen. Okay, there's no value I can put in to equal 0. So you have an asymptote both vertical and horizontal. Maybe I'm not giving you guys enough information. This is good. This is very good. So there's your asymptotes. Were you thinking there was a vertical one right down here?
Yeah.
Good thought. Okay. All right.
Are we supposed to
A
be-
little more than receptacles than I planned. Any questions? All right. Let's go through this. Exponential. F of x equals some value. We don't know what it is. A is an element of a real number. It's like 5 or 7 or -10 times my ratio. We know that to the x power. And that r can be any ratio like 2 or 3. Things are doubling, things are tripling, things are being cut in half. Exponential. And then of course the exponential looks something like this.
Does it have any asymptote? Oh, it has one.
And this one does have an asymptote. Where's it at?
The X.
It has a horizontal, right? Because once again, there's no value I can put in to make that equal to 0. Actually, I wrote that wrong, but you get my notes. Okay, last one. This one we're not going to get to until much later in the year, but it's logarithmic. How many of you have heard that term before, logarithmic? Yeah? Because it should be introduced in Algebra 2, maybe the end of Algebra 1, depending on how far you got. But it should be introduced in Algebra 2. So f of x. And you got to bear with me on this one. Once again, I'm not going to explain everything about logs just yet. But it actually has the word log in it, L-O-G. It's kind of like sine, cosine. Okay, log, L-O-G, x. And its graph is going to look something like this. With arrows on the end. Someone, please raise your hand. Don't just shout out the answer. Someone raise your hand and tell me, what does that kind of look like? What other functions? Yes, ma'am. Huh? Say again? It does. It's actually the inverse of the exponential. These two are actually inverses of each other. So that would mean it has a vertical asymptote along the y. This one had one across the x, this one has one across the y, and they are inverses of each other. Okay, I'm going to pause the video, take a few minutes. I would like to go on today, so I'm not going to give you like an infinite amount of time. But go down through here and fill out domain, range, x-intercepts, y-intercepts, etc. in this column here. Okay? I'll give you a few minutes and then I'll take any questions. Yes?
Why does that one have a log of A? Is that just order? Is that different?